After all this work learning how to find where two lines intersect, there must be a reason for doing it, some sort of purpose or type of problem you can solve using those techniques. So I have an example here of something that you would solve with a linear system. Now, the first thing you're going to do when you look at that block of text is you're going to not panic. It's just information. Some of it is unnecessary, and we're just going to take a minute to sort of dig through this and see what we can find. So we're going to read the whole paragraph and then we'll pick it apart. The McPhail and Beavercrest are sending their grade 8 grads to Wonderland. McPhail sends 4 full buses and 2 full vans for a total of 152 students. Beavercrest sends 3 full buses and 5 full vans for a total of 156 students. Okay, so first thing, McPhail and Beavercrest are sending their grade 8 grads to Wonderland. I have a feeling that you don't actually care about that. I'm just going to strike it out there. It's not that it's not important, it's just the context for the question. There was no mathematical information in that particular sentence. Down here, how many people fit in each vehicle? Well, there's 2 types. There's buses and there are vans. And you notice that buses and vans are mentioned for both schools. So I'm just going to write B for bus, V for van. Okay. Now I've got a sentence here. Blah, 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 period. We're going to try and convert that sentence into an equation. So McPhail sends 4 full buses. 4 buses. And 2 full vans. For a total of 152 students. So once I identified that I was going to use B for a bus and V for a van, this sentence literally reads 4 buses and 2 vans is 152 kids. So there wasn't a lot of math magic to pull out of there. It's really just literacy. Right? Can you read a sentence and convert it to an equation? So this sentence here, Beavercrest sends 3 full buses and 5 full vans for a total of 156 students. Well, that would be 3 full buses and 5 full vans for a total of 156 kids. Okay, so we have 2 equations here. Now that we have 2 equations, it's just a matter of using substitution or elimination in order to figure this out. So I'm going to look at my coefficients over here. I have a 4 and a 3 and a 2 and a 5. No matches, so I'm going to have to scale one of these equations or both of them up in order to get a match. If I look at these in front, if I were to triple this line, I would have a 12 out here. If I were to quadruple this line, I would have a 12 out there. I would have a match. So I'm going to do that. 4 times 3 would be 12 buses. 2 times 3 would be 6 vans. Now if I tripled the number of buses and I tripled the number of vans, I should be tripling the number of people who go. 152 times 3 will be 456. All right, so 3 buses times 4 would be 12 buses. 5 vans times 4 would be 20 vans. And 156 times 4 would be 624. All right. I have a match now, so it's just a matter of eliminating the variables. 12 minus 12 would be gone. 6 subtract 20 would be negative 14 vans. Now, that doesn't make sense in the context of the question, but don't panic. It'll come out in the wash. 456 minus 624. I don't trust my brain to do that at this time of day. 168 negative. So to finish, I just have to divide both sides by this negative 14, and I get V equals 12. Now, what does that mean? Well, earlier, I decided that V stood for vans, so that must be the number of people that fit in a van. So when I was asked how many people fit in each vehicle, well, I've got one of them. I know that 12 people fit in a van. I just don't know how many people can go in a bus yet. Well, that's what these equations are for. So if I take the van number and I feed it into any one of these, I should be able to get the bus number. So I'm just going to choose this one because it's convenient for the space I've got here. 3 buses plus 5 vans, which I now know hold 12 people, gives me 156 students. So 3 buses must be 5 times 12 is 60. Subtract 60 from the other side. That's 96. Let me check that. Yep. So to finish, I just need to divide by 3. And 96 divided by 3 should give me 32. So, when McFell sent 4 full buses and 2 full vans for a total of 152 students, the only way for that to have worked out is if the vans held 12 kids and the buses held 32. There's another long sequence of text here. Let's read it and then we'll dig it apart. The Dundalk Little Theatre is putting on a production. Opening night, they sell 28 adult tickets and 5 child tickets for a total of $155. They sell 25 adult tickets and 20 child tickets on the second night for a total of $185. How much are they charging for each type of ticket? Well, there's your question. So when it asks for each type of ticket, what types of tickets are there? Well, I saw something about adult tickets right there, and then again here. So A for adult. And I saw something about child tickets there and there. So C for child. I'm having trouble with ages today. Okay, so let's go through this text and get rid of what's not unnecessary and highlight what matters. The Dundalk Little Theatre is putting on a production. Yep, gotcha. That's just context. No math information there. Opening night, they sell 28 adult tickets. Okay, so 28 adult tickets. And I'm going to add something to that pile. 5 child tickets. There they are, 5 child tickets for a total of $155. So 28 adult tickets and 5 child tickets has to add up to 155. On the second night here, they sell 25 adult tickets. There we go. And 20 child tickets. for a grand total of $185. There I have my two equations to work with. Once I have those, it's just a matter of using the elimination method. I look at this and this, I don't have a match. I look at here and here, I don't have a match. So I'm going to have to scale one or both of these equations up. I could multiply this one by 25 and this one by 28. That's going to give me really big numbers. If I look at this second letter here, the child tickets, if I just multiplied this line by 4, I would have matching coefficients here, 20 and 20. So I wouldn't have to have such big numbers. So that's what I'm going to choose to do. Take this equation and multiply it by 4. So 4 of these would be 112, I think. Let me check that. Yep. 4 of these would be 20. 4 of these would be 620. I'm going to check that too. Yep. And this one, I'm just going to leave it alone. Alright, so I have a match in this column, so I'm able to eliminate them. So 112 subtract 25 gives me 87 adult tickets. 620 subtract 185 is $435. So in the logic here, if this many tickets and this many of this type of tickets add up to 155, if I quadrupled these and quadrupled these, I would end up quadrupling the money I made. So there it is. Now between these two lines, I know that this number here is some adult tickets and some child tickets. I know that this number here is some adult tickets and some child tickets. What I don't know is how much of each pile belongs to which type. But when I have a match like this, I know that in this pile there are exactly 20 child tickets, and in this pile there are exactly 20 child tickets. So the difference between these two numbers only comes from the difference in the adult tickets, because the kid pile matches. That's sort of the theory or the logic behind this. So if I figure out how many more adult tickets were sold in this line, and I figure out how much more money there is in this line, then I should be able to distribute that money over the number of adult tickets and figure out how much each costs. So to finish, got to divide out this 87. I get 5. So an adult ticket is costing $5. Now it did ask me how much they were charging for each type, so I need to figure out the price for a child ticket, and I'm just going to have to backfill it. I could put it into this one, this one, this one, this one. It doesn't matter. Any equation that has an A and a C. I'm just going to use this one because it's conveniently placed on my mess of writing here. So 25 adult tickets. Oop, but I know adult tickets are worth $5 now. Plus 20 children's tickets is $185. 25 times 5 is $125. So $125 of this total was from the adult tickets. So if I take that out of the pile, 185 subtract 125, I get $60. So these 20 child tickets have to have brought in $60. So divide each side by 20. C is 3. So child tickets for this particular production are $3, adult tickets are $5. We have a third example here. Mr. McDonald and Ms. McCaffrey are planting gardens at their homes. Mr. McDonald purchased 5 rose bushes and 3 junipers for a total of $151. Ms. McCaffrey purchased 4 rose bushes and 6 junipers for a total of $182. How much does each type of plant cost? Okay, type of plant. So I've got rose bushes there and there. So R for roses. And I have junipers. There they are, junipers, and there's some more junipers here. J for junipers. All right, now Mr. McDonald, that's me, of course. Ms. McCaffrey was a legendary math teacher at Grey Highlands, I think from 1981 to 2015. So she's been retired for almost 10 years now. Ask your parents. If they went to Grey Highlands, they'll know who Ms. McCaffrey is. I digress. Mr. McDonald and Ms. McCaffrey are planting gardens at their homes. No math information there, so we're going to strike it from the record. Don't worry about it. Mr. McDonald purchased 5 rose bushes. Okay, R for roses. 5. Oh, that's gross. Whoa. 5 rose bushes and 3 junipers for a total of $151. Now, Ms. McCaffrey purchased 4 rose bushes and 6 junipers for a grand total of $182. All right, so there are my equations. It's time to eliminate. I look at my numbers. I don't have a match here. I don't have a match there. I could do this row by 4 and this row by 5 to get 20 as a match in the front. Or I could just double this one. 2 times 3 is 6, and then I'd have a match. That feels easier to me, so that's the one I'm going to do. 5 times 2 would be 10 rose bushes. 3 junipers times 2 would be 6 junipers. And if I double the number of plants I buy, I'm going to double the cost. So it would be $302. I didn't change this one at all. 4 rose bushes and 6 junipers was $182. So again, I can see that in this line, I paid more money than I did here, but because I paid for more rose bushes. We had exactly the same number of junipers. It's the rose bushes that are making this number bigger. So if I take the junipers out of the pile, this minus this is gone. I can see that this extra money is because of the 6 extra rose bushes. 10 minus 4 is 6. And this money, take that money out, 302 minus 182 should be 120. Let me check that. Yep. So the extra money here was only because of those 6 extra rose bushes. So if I divide everything by 6, I get R is $20. So the rose bushes cost 20 bucks each. Well, I still need the junipers, so I'm going to fill that R into any equation that has an R and a J. Again, for the last time, I'm choosing this one because it's located conveniently on my board. 4 rose bushes, which I know cost $20 now, plus 6 junipers is $182. 4 times 20 would be 80. So $80 of this total came from the rose bushes. So if I take that out, all that's left is what I spent on the junipers. So 182 subtract 80 would be 102. Divide both sides by 6. 102 divided by 6 is 17. So the rose bushes cost $20 and the junipers cost $17.